back, and we're actually going to be looking at the last topic that you're going to be doing in grade 10, and that is vectors. Traditionally, we're not able to finish this topic in grade 10 whenever we have a regular physical school, but I think that the coronavirus issue has allowed us to be able to finish vectors this year, and that's a positive. Okay, so we're going to be looking at vectors, and the first thing we want to discuss is the difference between a vector quantity and a scalar quantity. Now, a vector quantity has both size. Now, there are two other words that can be used for this word size. It's magnitude and direction. This should be an I, my apologies. So it's magnitude and direction. So whenever you hear the word magnitude for a vector, it means size or length. So a vector quantity has two things. It has magnitude, which is also called size or length, and it has direction, extremely important. So a vector quantity has both magnitude and direction. Now a scalar quantity only has magnitude, and again, magnitude means size or length. So that's a big difference. So a vector quantity has magnitude and direction, two things, while a scalar quantity has only one thing, which is magnitude. So just to give a rough idea of a quote-unquote vector statement would be, for example, Kingston College is northwest of the National Stadium, of a distance of maybe about 1 kilometer. So that's a rough example of a vector statement. Kingston College is northwest of the National Stadium at a distance of 1 kilometer. An example of a scalar statement would be Kingston College is 1 kilometer from the National Stadium. So there's no direction given with a scalar quantity. But as far as vector goes, you must state direction and you must state magnitude. So direction is extremely important. So a vector quantity, which is a focus, has both magnitude and direction, and magnitude means size or length. Okay? Alright. Now here's an example. Focus on this black line for me. So here's an example of a vector. Okay? So if you notice here, there's a line segment. Sometimes we call it line, so I might call it line, but it's really a line segment. What it can be measured is a line segment. And there's an arrow on it. Very important that the arrow is present. So the arrow indicates direction, and what it does is make this diagram here a vector, because you have magnitude, which means you can take a ruler and measure the length of it, and we know magnitude means length or size. So the length of the vector can be measured with a ruler. And also the arrow dictates that it has direction, which makes this diagram here a vector diagram. So here we have an example of a vector because it can be measured and the direction is given. So we have magnitude and direction. Now this vector is called AB and not BA. And notice that the arrow is pointing towards the letter B, as it is in this case, pointing towards the letter B. If I had wrote AB without this, I wouldn't be describing a vector. It must have the arrow above it because the direction is extremely important. Without this AB here, for example, would represent, for example, the length of a side of a triangle, or just describing the side of a triangle or a polygon. It only has magnitude, but with the arrow above it, it has direction. And the direction is clearly going this way. So the arrow is pointing towards B. And the arrow of a vector always points towards the head, which in this case is B. So if the arrow always points towards the head, in this case it is B, then this letter A here must be the foot, sometimes called the tail. So the arrow of a vector always points towards the head, and the other letter would be the foot. So starting point here, going up here, and that's the direction. Without this, it's not a vector. Without the direction, without the arrow, it's not a vector. Okay, so we're just making that sure and clear. All right, so we're getting this out of the way. Now, here's another example of a vector, and observe clearly where the arrow is pointing. The arrow is pointing towards the letter D, which means that the letter D is the head of the vector. So that's the head. And of course, this would be the foot or the tail. Okay? So the arrow always points towards the head of a vector. And of course, in this case, the head is D. So this vector would be called CD. And of course, the arrow is pointing towards D. So it's indicating the direction of the vector. Again, you could easily take a ruler and measure the length of it. And the length of a vector is also called the magnitude or the size. And the direction indicates where the vector is going. Okay? So here's another example. Okay, so here we have two other examples. Here, let's look at this one first of all. What do you think this vector would be called? Would this vector be called VM or MV? What would it be called? Because if you call it the wrong thing, then you're describing a totally different vector than what is on the paper. So this vector here, would it be called VM or would it be called MV? It's extremely important. Now the arrow is pointing towards the head, and this would be the foot. So it therefore means that this vector would be called VM. But if I write it like this, without the arrow, it's not a vector here. So I'd have to indicate clearly where the arrow is going, and the arrow is going in the direction of the head, which is letter M here. So this would be called vector VM. Let's take a look at this one. Is that a vector? It is, because that vector there has magnitude, which means it can be measured, and it has direction. So it is a vector. But what is it called? Is it called TU or UT? Now, based on the fact that the arrow is pointing towards T, it means that T is the head of the vector, and therefore U would be the foot. So this vector here would be called UT, and of course you'd have to indicate the direction of the vector. All right? Okay. Now let's take a look at this. Well, that's a giveaway there. It says that that's not a vector, but the big question is why it's not a vector. And if you answered correctly, saying that there is no arrow present, then you're right. Without the arrow, that's not a vector. So if you were to draw that and tell somebody that's a vector, you'd be very, very, very wrong, because there's no arrow indicating direction. And a vector quantity must have magnitude. Clearly the magnitude is there because it can be measured, but there's no direction. And a vector quantity must have both magnitude and direction. So without the direction, without the arrow there, it's clearly not a vector. All it is AB. That's all it is. All right? AB, or what they want to say BA. And that is why sometimes when we're calling the side of a triangle or a rectangle or a polygon, we can say AB or BA because there is no direction indicated. The focus is on magnitude. So clearly, this is not a vector. You can call it AB or BA because the direction is irrelevant, which makes this a scalar quantity. So this is a scalar quantity simply because it only has magnitude. So this is not a vector. Okay? So understand the difference now. So without the arrow, you're not representing a vector. So I want to be very clear with that. So if the teacher asks you to draw a vector and you just draw a line segment like that, you could actually call it AB or BA. That's clear because there's no arrow present, so it's not a vector. Okay? All right. Now, the next thing that we want to do is understand column vector form. All right? Very, very important in progressing in vectors. Now, here we have something looking like a 2x1 matrix here. But since we're dealing with vectors, we're going to call it column vector form. But there is a connection with matrices, as you would have seen, especially the CSEC boys from some of the past papers that you've been doing so far. So obviously there's a connection between vectors and matrices. That's why they've put it in one topic called vectors and matrices. Now, the top number, you must always look at the top number first. First. Because the top number is going to dictate whether you're going to go right or left. If the top number, let's say the top number is 8, that clearly is positive 8, that means the vector is going to go to the right. And if the top number here is a negative number, that means the vector is going to go to the left. So the first thing you do is you look at the top number to dictate whether it's right or left. So when you want to know the movement of a vector, the first thing you're going to ask is it moving right or left? That's the first thing. So when based on the sign, you'll know whether it's moving right or left. Afterwards, then you look at the bottom number. If the bottom number is positive, the vector is going up. If the bottom number is negative, the vector is going down. But the first thing you must do is determine whether it's moving right or left, and then you determine whether it's going up or down. That is column vector form right there. Now, let's take a look at what is happening here with these vectors here. Let's look at this first vector. This first vector is called PQ. Now, based on what we're saying here, how is vector PQ moving? Clearly, P is the foot and Q is the head. How is vector PQ moving? Now, it has -3 at the top. So that's the first number you look at, the number at the top. Now, it's a negative value, and if it's a negative value, that means the vector is moving left. And the bottom number is what we look at next. This is +2, and because it's +2, then the vector is going up. So here's how you describe vector PQ. We have a vector called PQ, and that vector is moving 3 spaces to the left because it's negative, and 2 spaces up because it's positive. So vector PQ is moving 3 spaces left and 2 spaces up. So we're just focusing on vector PQ for a second. PQ is moving 3 spaces to the left and 2 spaces up. So what I'm going to do is I'm going to demonstrate how to actually draw vector PQ on a graph sheet. And I'm going to use a large graph board for you to understand clearly how to draw the vector. Alright? So as a matter of fact, let me put this here and just demonstrate that to you. Right, I'm just going to put this over here so you can see PQ there. So I'm going to try to get that vector drawn. Now, to be honest with you, we're dealing with free vectors, and when you have free vectors, that means that the foot can be placed anywhere. But when we say anywhere, what we're actually talking about is on the lines that are 1 centimeter apart on your graph sheet. This is a large graph board, obviously, but using a graph sheet, you're only dealing with the lines that are 1 centimeter apart, not the small ones in between, not the 4 small lines in between, the lines that are 1 centimeter apart. So what I'm going to do here is demonstrate how to draw vector PQ on graph sheet based on how PQ is moving. It's moving 3 spaces to the left and 2 spaces up. So the first thing I'm going to do is I'm going to indicate a point that represents the foot. And remember, the arrow always points towards the head. So clearly the head is Q and the foot is P. So I'm just going to put P right there. And I'm going to count the spaces now based on how it is moving. So the vector is moving 3 spaces to the left. So it's 1. You never count this as 1 because when you're running a race, you haven't moved any meters yet or covered any meters. So it's 1, 2, 3 spaces to the left. And let me just pull it down a little bit so you can clearly see. So again, I'm putting P here because P is a foot. So it's 1, 2, 3 spaces to the left, 1, 2 spaces up. So this would be Q, which represents the head of that vector. So again, vector PQ has P as a foot, Q as the head. It's moving 3 spaces to the left because it's -3 and 2 spaces up based on the fact that it's +2 there. So all I need to do is connect P to Q, just like this. And remember, without the arrow, it's not a vector. Right now, this is just a scalar quantity. So I have to put on the arrow, and the arrow always points towards the head. And clearly Q is the head here. So that completes my vector diagram. Okay, it's as simple as that. Now take a look at this for me. 5 and 1, and that is vector A. Now vector A is moving 5 spaces to the right because it's +5 and 1 space up. So vector AB is moving 5 spaces to the right and 1 space up. So we're going to try to demonstrate vector AB here on the graph board. It's moving 5 spaces to the right and 1 space upwards. So let's see if we can get that done. So I'm going to put this here. I hope you can see this right here. And remember, the arrow always points towards the head. So clearly A is a foot. So I'm going to put A here. All right. And I'm going to move 5 spaces to the right and 1 space up. So vector A, so I'm going to count 1, 2, 3, 4, 5. That's 5 to the right because it's positive 5 here. And then 1 space up, which goes 1. So this should be B here. So again, A is a foot of the vector. A is a foot, B is the head, and it's moving 5 spaces to the right. 1, 2, 3, 4, 5, and 1 space up because it's positive 1, like that. So all I'm going to do here is connect A to B, just like this. And of course, I need to indicate where the head is using the arrow, and that would be like that. So that is an example of, or those are 2 examples of how you represent the vectors there. So the next one that we have here is US, vector US, and that vector is moving 4 spaces to the right and 3 spaces down. So we're going to try to draw this vector US. We have 4 and negative 3. Remember that 4 and negative 3, the foot of that vector is U and the head is S. So we're going to represent that vector on the graph sheet as well. And let's see if we can get this done as easily as possible. So I'm just going to indicate that here. I'm just going to try to put it there so you can see it. US. So the foot is actually at U. So I'm just going to put that there. That is U. And again, the vector is moving 4 spaces to the right. So it's 1, 2, 3, 4. And then 3 spaces down because it's negative 3. So it's 1, 2, 3. So what letter comes here? S. So all I will need to do is connect the 2 points. Just connect the 2 points here. Again, the foot is U. So we move 1, 2, 3, 4 spaces to the right because it's positive 4. And 1, 2, 3 spaces down because it's negative 3. Remember, US, positive 4. That means 4 spaces to the right. And negative 3, which means 3 spaces down. So again, 1, 2, this is a foot. 1, 2, 3, 4. 1, 2, 3. And of course, the arrow points towards the head. Okay? So that is how we represent vectors on graph sheet. All right, gentlemen. All right. So this concludes our first video on vectors. I hope you found this video insightful, and I'll see you guys on the next video.